for the food prototype, we use soil, plant, coconut husk, cable net and cable tie. So for the soil, 1 kilo I think for ringgit. For the plant, around 6 ringgit for one plant. For the coconut husk, one packet 5 ringgit, and the cable net 3 roll 10 ringgit. For the cable tie, we used to tie the coconut husk with the cable net. So for the cable tie, for the price for the cable tie is 2 ringgit per cent. So that's all. Thank you.
Yes, my name is Pertin. So today I'm here to explain the hardware of our project. So this is the soil moisture sensor, and the price of soil moisture sensor is 2 ringgit 50 cents. And the function of soil moisture sensor is to measure and estimate the amount of water in the soil. And this is ESP22. The price of ESP22 is 24 ringgit. And the function of this is to collect the data and transfer the data to this laptop. And then the jumper cable, the price is 2 ringgit 50 cents. And this is called temperature humidity sensor. The price is 14 ringgit. So the function of temperature humidity sensor is to sense and measure the relative humidity in the air. It is also measure both moisture and air temperature. So the warmer the air temperature is, the more moisture it can hold. Thank you.
Hello, my name is So for today, I'll be talking about the software that I've developed to help protect mangrove area by monitoring key environmental factors like soil moisture, humidity and temperature. So to do this, we use sensor connected to the Arduino. So this sensor, all the sensor to the Arduino and Blink app. So the soil moisture sensor is placed in the ground to measure water level in the soil, while the humidity and temperature sensor track the surrounding environment. So once we have put our water inside the soil, so it's going to change the data.
Boleh ke? No. Okay, di sana kan?
Yeah,
okay.
And then the other one is at the Arduino app. So this one, data is going to change. So the data is going to send to the data from the sensor is going to be sent to my laptop. So it's easy to us to monitor the condition in real time. So this system is important because it helps ensure the mangrove ecosystem stays healthy by providing us with the data needed to take action if the condition changes. That's it. Thank you.
Hi everyone and hi to madam. My name is Lee Jahao and today I'm going to explain about the contextual deployment. This is my part for the final project. So my part is planning a small scale that how we put all the thing for our final project, how we arrange the IoT device, the barrier and all the things, for example, and how this small scale can help to also for the big scale for mangrove project. So for the scalability feature, so the first one is modular IoT device. The soil moisture sensor, temperature sensor, and humidity sensor are compact and modular, allowing easy replication across large area. Wirelessly connectivity simplify deployment without extensive cabling. So which means that the connection will be wider, be big, but no need a lot of cable. No need an extend cable. So the second one is sustainable power. So each device is equipped with a small solar panel, ensuring energy independent and reducing the need for external power source. So for each device, we connect to a solar panel, a small one. So in the morning, they will receive the energy to let the device working and also restore some energy for night using it. So the third one is flexible deployment. Sensors are strategically placed at critical environment point. The first one in near root for soil data, the second one on pole of air and soil temperature, and the third one within canopies for humidity. This configuration can be expanded to the cover broader mangrove zone. So the fourth one is wireless network. IoT devices communicate wirelessly, forming a scalable network that can transmit data to central hub in real time, even in remote area. So it means it's communicate with wireless with Wi-Fi network, so easily to capture, so let the device easily to capture the data at the fast time as soon as possible. The last one is ecosystem integration. The devices are designed to minimally disturb the environment, blending seamlessly into mangrove setting to preserve the natural ecosystem. This design can easily scale from small prototype to large conservation effort by replicating module and expanding network while maintaining cost efficiency and environmental harmony. That's all from me. Thank you.
Hello, my name is Rio, and as my reflection through contributing for my team on the final project, I would say this revolved around the data flow and visualization for an IoT-based environmental monitoring system. My specific role was to design the flow of data from sensors to the central monitoring unit and create a visualization flowchart for interpreting the data. Through this journey, I not only improved my technical skills, but also learned a great deal about project management and collaboration. Completing this project has been very valuable for me. It allowed me to deepen my understanding of IoT systems and their real-world applications, develop my skills in creating detailed flowcharts and data visualization tools, and I also gained practical experience in breaking down complex systems into manageable components. I also discovered how important clear data presentation is for decision making, as the visualization component transforms raw numbers into actionable insights. When I first started working on my part, I knew the basic concepts of IoT and data visualization. However, working on a project of this scale required me to dive deeper. For example, like function of wireless communication protocols and how to structure data efficiently for processing and visualization to create a detailed flowchart that capture both technical depth and clarity. So in conclusion, I think this project has been an enriching experience, both technically and personally. It challenged me to apply my knowledge in a practical setting, think critically, and communicate complex ideas clearly. Thank you.
Hello guys, my name is Pavitrishan Nathiappan and today I'll be presenting the documentation and the reporting part of the final project. So starting off, I'll be talking about the executive summary. The health of the mangrove ecosystems is declining due to environmental stresses like soil erosion, sea level rise, and the effect of tropical cyclones. The mangrove continues to lose much of the biological value as a natural storm barrier and carbon sink globally. Current conservation techniques very often lack viable and affordable options for long-term monitoring and preservation. The challenge lies in developing a methodologically sound and environmental friendly technique that can handle these problems effectively. This model tracks the implementation of a comprehensive mangrove monitoring system from Coconut Husk to the Internet of Things (IoT), addressing soil erosion and collecting environmental data, make the system an effective tool for enhancing the conservation of mangroves. It addresses long-term sustainability and ecosystem health, providing a structured, repeatable, and efficient approach. So basically, we have created a prototype. This prototype will be used in the real life environment, the mangrove system. It has sensors which helps us to analyze the data and also store the data in case if there's a risk of if the sensors are getting a high reading or low reading, so it'll be we will be alerted. So basically, this prototype of this component, the components involved is the Coconut Husk Barrier, which acts as a natural barrier to reduce the erosion on the coasts and limits the impact of high tides on mangrove ecosystems. It also provides physical support for placing the IoT sensors while blending into the environment. Next up, the most important one is the IoT sensors. The sensors is function to monitor the critical environmental parameters to evaluate mangrove health and its other properties. So basically, there are like 4 to 5 sensors. The sensors involve is the humidity, the temperature, the soil, and yes. So the sensors are involved in retrieving the data, the real-time data which is embedded into the soil. We'll see that later on, and retrieve the data in the interface we have produced, which is coming to the monitoring system. The app used will be the monitor where data is collected from the sensors and displays it for us to analyze. The next step is power source. This power source is used to ensure the operation of sensors are uninterrupted even remotely. So the next step is a system architecture diagram, which is basically the flow of the system in action. So starting off with the sensors, the soil sensor, the coconut husk sensor, the temperatures, and the humidity. The sensors data will be collected and run into the monitor, and we can see the erosion level and also the water level from this monitor. And also it also generates alerts and reports if, let's say, the sensors are giving a high reading or maybe a low reading. And yes, so next up is the prototype and the simulation part, where we have actually tried our prototype in real life action by creating a small environment which is uh, similar to the real life environment in the mangrove system. So starting off with power on the prototype system, ensure all the sensors for soil, temperature, and humidity are connected and functioning. And also the dashboard analyzes the dashboard shows us that the system status is ready. For example, the interface we created, it shows ready, so the sensors are good and functioning. The next step is the data collection in the process, where the sensors start collecting the real-time environmental data from the mangrove area. The data streams into the system, appearing as a dashboard at the soil. As you can see, the soil temperature, the soil's, the soil moisture, the temperature, and the humidity. And these are all the data's values. And it changes every time. If there's a change in, let's say, the water level has been increased, and the data here will be changed to the exact current data. The next step is a visualization on the dashboard. There'll be graphs and also indicators on the dashboard update in real time to reflect. Sorry. And the next step is the decision making assistance. As you can see, the system provides recommendations based on the data. For example, soil moisture is critically low. Active irrigation system is like that. So it gives us a report or an alert on what we should do for to see if the data has changed or not. The operator can review the recommendation and take action, such as enabling water supply through toggle button on the dashboard, something like that. So as you can see, this is all the sensors working. And monitoring and feedback. The system continues to monitor changes in real time after actions are taken. And finally, the reporting and logs. The system logs all the data, alerts, and actions for future analysis. And the user can generate summary reports for performance evaluation and decision-making records. As you can see, these are all the reports stored. Yes, so this is the first, second, and third. So it changes based on every second, and that data is particularly stored. And that is all from me. Thank you very much.
As you can see here, the water is swimming, but the coconut husk successfully protecting the plants from the waves. It's proof that this mangrove system can protect the plants from the whales. Okay, for the improvement for the system, we can add an advanced warning system. Install weather monitoring systems that can detect lightning, storms, and advanced alarming for protective measures. For the next one, we can include lightning protection for equipment, install surge protectors and lightning code to safeguard monitoring equipment and sensors. This will help prevent electrical damage during storms. Thank you.
Assalamualaikum, hi, my name is Simon Shafiq from class CCS 17303 about system electrical design. And this is our final year project. It's about IoT integrated Coconut Husk Barrier for Mangrove Protection. This is a functional prototype for a sustainable environmental monitoring system. The system integrates coconut husk as a protective barrier for mangrove and uses IoT sensors for continuous monitoring of key environmental factors. This system should support both environmental sustainability and data-driven decision making.